Okay, so let's talk about these. Okay, we'll go with that. So, I don't know how many of you did the quiz that's due today. We'll talk about that in a little bit. But really, the ideas are pretty easy. What's hard is trying to make your answers look like the answers that were on the answer key, because they do this to all their answers. Those came from the book, the textbook. And you might not necessarily think to do the same things that whoever wrote those did. And that's okay. So what I want to do is review some of this algebraic simplification so that these things don't become a stumbling block to us. These are operations that we need to be able to do without having to think too hard about it, so that we can focus on the pre-calculus principles that we're going to learn. And so we're going to take a little bit of time today to review these algebra skills. That's what we're doing right now. So this first one, I think we all did pretty well on, because we distribute a lot. So on number 1, we're just going to take that x, right, and distribute it times each of these. So x times 2x squared, 2x cubed, x times x is what? And then what would x times 1 over x be? X times 1 over x. So I'm multiplying a fraction by a non-fraction, right? And so I can, to do that, it might help to put the x over a 1, so they're both fractions. And if I multiply straight across, yeah, I get x over x, and that reduces, of course, to just 1. So it would be 2x cubed plus x squared minus 1. So we distributed that. Okay. So the little details that we want to be able to we want these not to be stumbling blocks, just to be little details that we're in the habit of solving. So here we've got 1 over x squared, and remind me, what does it mean to square something? Multiply it by itself. So this means 1 over x times 1 over x. And how do I multiply two fractions together? Yeah, straight across. So 1 times 1 is 1. X times x, x squared. So 1 over x squared. Okay. Like so. And if you remember your Algebra 2 properties of exponents, you might remember when you have an exponent, really you're just squaring the top and you're squaring the bottom like that, which is what happens when you multiply two fractions together. And if you don't remember it, just write it out, square it. Okay, number 3. So again, on number 3, your gut probably tells you, hey, I need to distribute this because I've got something times a set of parentheses. So the square root of x times x is simply just the square root of x times x. Actually, it looks a little bit better if you write it in the opposite order. X times the square root of x. Okay, so that's this first term. And then the square root of x times 1 would be what? Yeah, just the square root of x. Okay? And that is a perfectly fine answer. Now, maybe it doesn't look that much simpler than this answer. It's really not. Does anybody remember any other way to combine these two things? So you notice you have two x's here, right? X and then a square root of x. There's one other way that we could combine these. We haven't talked about it at all this year. So there's another way to write the square root of x using exponents. Yeah, so the square root of x is x to the 1/2. I remember that from last year? Oh, you will. So if I think about it like that, then how would I do x times x to the 1/2? How do I multiply two numbers together that have the same base but different exponents? By the way, what's the exponent on just x by itself? A 1. So what do I do with those exponents? Yeah, I add the exponents. So 1 plus 1/2. What's that? Well, 1/2, but we want to write it as an improper fraction. Because mixed numbers are dumb. Nobody uses them. I'm just kidding. Okay. So 2 times 1 plus 1 is 3, so that's x to the 3/2. So alternatively, I could write this term right here as x to the 3/2, and then this term right here is x to the 1/2. So that would be another thing that will be useful at some point during the year. So I just wanted to bring that up. But if you leave it like this for now, that's fine. Okay. Number 4. So here, I asked you to combine these fractions. What fractions? I only see one fraction. Well, I want to make these other things fractions. So how do I make something that's not a fraction look like a fraction? Put it over 1. How can I write down my inner thoughts without a red pencil? Okay. They're going to be in blue today. So I'm going to put each of those over 1. So I make them both a fraction. And so that's fine. Why did I make them fractions? Well, I want to combine these fractions into a single fraction. And what do I have to do before I can add or subtract fractions? A common denominator. What would be a good common denominator to use? 1? 10? Okay, x would be a good choice, because I can easily turn each of these denominators into an x to make them match. I just have to multiply the denominator by x. But that's not all I have to do. What else do I have to do? Yeah, I have to do the same thing to the numerator, or else I'm changing the value of my fractions. So that gives me 4x cubed over x minus 2x over x plus 1 over x. So this is the same expression as the original one. They would be equivalents. I've just rewritten it in a convenient way. So if I just multiply the bottom by x, I'm changing the value of my fractions. I don't want to do that. And now once they all have the same denominator, I'm going to combine those into a single fraction and give it my common denominator. And then what would go on the top? Yeah, 4x cubed. I just subtract and add the tops together. 4x cubed minus 2x plus 1. And I put them all over the same x. And like we talked a little bit about in the last class, this is going to be an important thing to do when we're talking about rational functions. It tells us where we have asymptotes, zeros, things like that. So that's why we want to try and write these as a single fraction. Number 5. Here we're going to do something similar to what we do in number 4, except kind of backwards. That was a good explanation. So, okay. I've got 4x squared plus 2x over x. I'll go ahead and rewrite it over here. What can I do? Yeah, so to try and reduce this fraction, I want to see, do the top and the bottom have any factors that match? Just like you do when you reduce a fraction with numbers. So if I had the number, if I had the fraction 10/15ths, and I wanted to reduce that fraction, what would I do? What would I look for? Say that again. Mackenzie? Right. So we look for some number, for something that we can divide out of the top and the bottom. Or in other words, a factor that the top and the bottom both have, right? So they both have a factor of 5. And you usually don't write it like this. You probably did when you first learned this, but that was a long time ago, and now you don't need to anymore. So we know that 10 is 5 times 2, and 15 is 5 times 3, right? And so if you write it like that, you can see the 5s cancel out, and you're left with 2/3. Same idea here. And same idea anytime you try and reduce a fraction. So is there a factor that the top and the bottom both have? So Kat, you said, sorry, say what you said again. Mm-hmm. Right, so x is a factor of the top. In other words, I can factor out an x like that. And that's interesting because x is also a factor of the bottom, and that'll allow me to cancel them. So what would be left over if I factor out an x? Yeah, 4x plus 2. So I can cancel out factors of the top and the bottom. X is a factor of the top, x is a factor of the bottom. So x divided by x is 1 over 1, like so. So essentially those go away. So what am I left with? Yeah, I'm left with 4x plus 2. So 1 times 4x plus 2 divided by 1. Just 4x plus 2. So I reduced my fraction. Now, that's not the only way you could work through that. I saw some of you do some canceling. You can cancel here, but there are some good ways to do it, and there are some bad ways to do it. So, here's a bad way to do it. Let's say you have this 4x squared plus 2x, and you want to divide it by x, and you say, oh, hey, look, there's an x there, and there's an x there. I'm going to cancel both of those out and get 4x squared plus 2. Did anybody do that? Somebody will. Somebody will do it on a quiz or test. Don't let it be you. So, what's the problem here? Well, the problem is in a fraction you cancel out factors, right? You don't cancel out. It's like I could write 10 as, well, I don't know. Anyway, it's not a factor of the top, so it doesn't cancel. There's a different set of operations here. So think about this whole top part like it's a set of parentheses. We have to do everything that's inside the set of parentheses before we can divide. So we need to try and factor this top part out. Factor an x outside of those parentheses so that we can divide it. Another way to not do this, and a very similar way that someone will also try to do, say, hey, look, an x, I can reduce that with this x squared over here. Therefore, I get 4x plus 2x. Oh, hey, that makes 6x, by the way. Did anybody do that? No, of course, no one would ever do that. Okay. So, again, same thing. So the way I saw some of you do this, a good way is to essentially take this x and reduce it with both of these terms. And that's what ends up happening. So you get 4x plus 2. So you'd have to reduce each term by x like that. And that gives you the same answer. So you can't just reduce one term or the other. You have to reduce them both. Okay. So there's some fraction review. But the safe way to do it, and what I'm always going to do, because it makes sense, because it's the same way you've been reducing fractions since, I don't know, 3rd grade, just to make up a grade. I have no idea what you do in 3rd grade. So the same way you've always reduced fractions is by looking for a common factor and then dividing it out. So I'm going to do the same thing over here. I'm going to look for a common factor and then divide it. Okay. Enough about fractions. Let's go on to number 6. Oh, wait. It's a fraction with a fraction on the bottom. A double fraction. So I guess we're going to talk more about fractions. Okay. And this we talked about the other day. So in this case, I have a fraction on the bottom of a fraction. So I'm dividing by a fraction. Does anybody remember what the easier way to do that is? I don't like dividing by fractions. I want to do something easier. Good. So instead of dividing by the fraction on the bottom, we're going to multiply by its reciprocal. So we're going to keep the top, and I'm going to change from dividing to multiplying, and I'm going to flip that bottom fraction. Okay. This is the same thing, only it's easier. Now, maybe I see what to do. So now I can distribute this x. Do I need to worry about this divided by 1 on the bottom? Is that doing anything? No, I can just ignore that, right? So I want to multiply the top by x, or x by this thing. Anyway, whatever I'm trying to say, there's what I did. So I'm going to multiply all this stuff by x. And I don't need to worry about the divided by 1 on the bottom. You could put it over 1, but it's the same. Okay, questions on that one? Yep. Okay. So number 7 combines, it sort of combines 3 of these other problems into a single problem. So now that we have all these skills, some of them involving fractions, some of them involving distributing, things like that, combining fractions, let's see if we can work through this last problem. So according to the order of operations, which of these things should I do first? Multiply by 3, square something, or subtract 4? Yeah, I need to do the exponent first, because that's how the order of operations works. PEMDAS, people call it. Parentheses, then exponents, then multiplication and division, then addition and subtraction. So we're going to square this first. And what's 1 over x squared? Yes, 1 over x all squared is 1 over x squared. So the first thing I'm going to do is rewrite that. Okay. So that's what we get when we square 1 over x, as discussed in number 2. Okay. So all I've done is replace this with something. I've rewritten. Now, we did the exponent. What's the next thing that should come in the order of operations? Yeah, we should multiply. So how do I multiply a whole number by a fraction? I can make them both fractions, simply as a visual aid. And then when I multiply these two fractions together, I multiply the top times the top, and I multiply the bottom times the bottom. Multiply straight across, people say. We do not cross-multiply fractions together. That's not a thing. You multiply straight across. 3 times 1 is 3. And then 1 times x squared is x squared. Okay. Great. And now I have this minus 4. Got to do something with that. So how would I subtract this fraction by 4? What should I do? Somebody give me a hint, because I'm not sure. Okay. Okay, so to subtract, to combine a fraction and a non-fraction, I want to make them both fractions, so I can put this over 1. And you said, what would be a good common denominator to use here? X squared. Okay. So how can I make this denominator an x squared? Okay. I'm going to multiply by x squared, which means I need to do what other important step? Yeah, same thing to the top. I want to multiply the top by x squared as well. So in other words, and I'm going to go ahead and write this out as a separate step, 3 over x squared minus, so that's going to be 4x squared over x squared. And I write out this next step just to prove the point. This is the same thing as 3x squared minus 4. Right? I could reduce this fraction. I would be working backwards. It's not what I want to do, but this is equivalent to the statement before. That's why I put an equal sign there. Okay, and now that these have the same denominator, I can write it as a single fraction with that common denominator, and then I'm just going to subtract the top parts. 3 minus 4x squared. Which also happens to be one of the problems from that take-home quiz. I don't remember which one, but it's one of them. Okay, so that was a lot of algebra. Any questions right there? Are your algebra skills starting to come back? I know some of you practiced algebra over the summer just to stay fresh. You didn't? I thought everyone practiced algebra over the summer. Isn't that what teenagers do for fun on summer break? Yeah, it's like I miss school so much. I'm just gonna solve some equations. It'll make me feel like I'm back with all my friends. No? Oh yes. Mine too, Alex. Yeah. Okay. So let's talk now about the take-home quiz. That doesn't look like anybody's turning yet.